Hello for each and everyone. Welcome to our second part of this session for our first course ever delivered by BNA Academy. My name is Salman Hadi, a petroleum geologist. Furthermore, I'm your moderator on the behalf of PetroNile Academy for today's session and for the rest of the session, inshallah, through this course. So, a very kind and warm welcome to Mr. Ghassan Bek, who is going to continue his effort to supplement us with all the essential information about the drilling fluid facts. Just a little introduction. Mr. Ghassan awarded a bachelor degree in petroleum engineering from Sudan University in 2006 with an over 11 years of experience in oil and gas industry. He is a senior drilling fluid engineer at MP Petroleum Services Oman since 2020 to the present. Also, he worked as a multi-field supervisor at Optimum Engineer Standard at KSA since 2018 until 2020. Furthermore, he is an engineer at African Drilling Fluids ADF Sudan since 2010 till 2018. Just a little housekeeping before we start. I want to remind and jog everybody's memory that the Q&A will be at the end of the session, so kindly leave and write down all your questions in the chat box. One more note, in order to catch up the wall favorable and required beneficial, make sure to attempt the next section. Now, without more ado, we will turn time to Mr. Ghassan.
Okay, thank you. Hello, everybody. Assalamu alaikum. We will continue this session number 2 for drilling fluids facts, practical approach, mud engineering series. Last session we talked about the introduction, and this session, inshallah, will be about the mud engineer's day approach. The agenda for this day will be the mud engineer's day infographic, mud testing, pilot testing, mixing procedures, mud reporting, and questions and answers in the last of the session, inshallah. Mud engineer's day infographic. The day of the mud engineer in the trick site, just around these 5 words. Now, here we have mix and test, analyze, act, and report. Mix. Mud engineer should mix the drilling fluids or the mud in the trick site, and after mix he has to go to test the mud parameters, and after the check results out, he has to analyze and act. Analyze to see what's the problem in the parameter, what should be going to enhance, increase something or decrease something. After this analysis, you have to act. That means you're going to add some chemicals or to add some dilution or like this. At the end of the day, he has to make full report, the DMR, daily mud report, and submit it to the client, to the company man and the office people. And also report here, sometimes you have to report something verbally while a day. For example, if you have some problem or like this in your parameter, or you have to go to do something in your mud, you have to report it this verbally to the company man and discuss. Sometimes you need some circulation to enhance your parameters, or if you will going to increase the mud weight before. Okay, this is now the day of the mud engineer. He has mix, test, analyze, act, and report. Mud testing, we have many tests for the mud engineer do it in the rig site, but the first one is the mud density. Mud density is commonly measured with the mud balance or pressurized mud balance. This picture now for normal mud balance. We have also pressurized mud balance. It's same technique for measuring. It's just only the pressurized mud balance is considered as more accurate. This accuracy for this mud balance is 0.1 ppg accuracy. Mud balance calibrated with the fresh water at 70 degree Fahrenheit should give a reading of 8.3 ppg or 1 sg. Here we have this is sg and this is ppg. Here we have also bcf and bsi per 1000 foot cubic foot. This is the four scales for the mud balance. It depends on the client request. Sometimes you report the mud density with the BBG in BBG. Sometimes you report it in SG, report it in kilopascal per meter, report it in BCF, pound per cubic foot. It depends on the client, but it's not difference. It's only in same. Only just if you client need it in kilopascal per meter, you will not find it in the mud balance. So you have to check in the SG and after that convert to kilopascal per meter. But the other units, it's available in the mud balance. Marsh funnel viscosity. Marsh funnel viscosity is the time required in seconds for a cart of mud. This is cart of mud to flow. We put mud here and till the full the Marsh funnel and let the mud going from this opening to fill this cart. We will find, we will check how many seconds to fill this cart, and that time we will report this Marsh funnel viscosity in seconds. And 1 quart of water should flow through a Marsh funnel in 26 plus or minus 0.5 seconds. So this is Marsh funnel and mud balance. This is will be a trick on the top of the mud tanks. It's not, it will not be in the mud lab. You will check by Direktman or mud tester or mud boy. This is all names for these mud helpers, crew, from crew to help the mud engineer. He has to check the mud density and the Marsh funnel viscosity every 30 minutes and record in the book. And the mud engineer check from the time to time and check the book and check also by himself. Rheology, this is rotational viscometer, sometimes we call it rheometer. This is used to measure shear rate and shear stress of a drilling fluids, and plastic viscosity and yield point are calculated directly from readings. We have 6 readings here, 600 RPM and 300 RPM and 200 RPM and 100 RPM and 6 RPM and 3 RPM. Also before long time, the old rheometer has 8 speeds. He has also 60 RPM and 30 RPM, but now it's just only 6 readings is enough for most of rheological models. We take the data from these readings and calculate it. BV, it's equal 600 reading minus 300 reading, and YB, it's 300 reading minus BV. This is as per Bingham Bohr law model. Here, this is a instrument. This is a gear. This is gear has 3 level. Here down and going little bit up, it will be in the center, and going in on the top, it will be an up. When be here is a down, and we have key here, high and low. In the other side is not now appear in this picture. We will put mud here inside, and this is will rotation with RPM as per this gearing and knob here adjustment. We have here this table. Viscometer switch if high, and gear shift knob in the down, and the switch in the high. This is will read RPM speed. Then you will read the reflection here from the top. 300 readings, the viscometer switch will be in the low and gear shift knob will be down also. 200 and 100 the gear will be up, and here switch will be high and low, high for 200 and low for 100. The shift when be in the center will reading will be for 600 for 6 rpm in the high and 3 rpm in the low. After record all these readings for 600, 300, and 200, 106, and 3. We can check the BV and YB, and also we can check some equations as per rheological model, and this will be calculated by software usually for Reynolds number and annulus velocity and everything in the rheology. It will discuss inshallah in next session. Also for gel strings, we will read just 3 rpm. After 10 seconds, we will read the first reflection. This will be 10 seconds of gel strings. And after 10 minutes, also in 3 rpm, we will read. This will take the gel strings for 10 minutes. Also, we have sometimes we need to report the gel minutes for gel strings for 30 minutes after half an hour. This is for viscometer. We have also for testing static filtration test. We have two types of test for static filtration. We have API filtration, and we have HPHT filtration, high pressure, high temperature filtration. This is test used to indicate the filter cake quality and filtrate volume loss for drilling mud under specific testing conditions. Its API filtration will be under 100 psi for 30 minutes and reported as a mil per 30 minutes, and filter cake thickness will be reported in 1 divided 32 inch. This is 1 over 32 inch. It's equal 0.8 millimeter. For HPHT, there will be the top pressure will be 600 psi, and pressure from the lower it's 100 psi. So test will be under differential pressure. It's 500 psi, and we will put it also in the high temperature. This depends on the bottom hole temperature. We can make the test up to 300 degree Fahrenheit. This is API filter press, and this is HPHT, high pressure, high temperature filter press. This here we put our sample inside here and apply from here 100 psi, and filtrate will come from this opening for half an hour. We will check how many get of mils of filtrate, and also this filtrate will use it titration for other tests. Here in HPHT, we will apply from the top here, it's 600 psi, from the bottom here 100 psi, and sample will be inside, and this heating jacket to heat or to heat the sample up to required or desired temperature, and we will put thermometer from the top here to check the temperature, and we'll adjust the temperature from here. When we reach the temperature to the 300 or 250 or 280 as per test needed, then we will start to apply the pressure and start the test. We will collect sample from here. You have to open and check from time and collect from time to time till finish the 30 minutes. And after finish the test, you have to reassemble the two this instrument and check the filter cake thickness and filter cake quality. For retort, this is to check water and oil and solids percentage. This is a volume percent of liquid phase. Water and oil are measured by heating a known volume of walnut, sometimes 10 mils, sometimes 50 mils, depends on the retort capacity. The liquid is evaporated from the mud. Vapor is condensed and measured as oil and fresh water in a graduated glass tube. Suspended solids are calculated by difference of liquid collected subtracted from wall mud volume. It's in percentage. You have here, this is a retort. This the cylinder for 10 mil, this cylinder for 20 mil. We have also cylinder for 50 mil. If we use, for example, this 10 mil, we will put mud here inside and we will put steel wool here inside to prevent the solids come from this and close this opening, because just we need the evaporation come to here, and will this is cylinder will be inside here the retort, and this evaporation will be condensate in this condenser and collect the liquid here. And after finish, this is like oven only, just to heat the sample and evaporate all liquid phase and condensate in this condenser and collect it here in this sample. We have 10 mil. If we get, for example, 8 mil liquid phase, oil plus water, that means we have 2 mil is the solids. This 2 mil in solid from 10 mil, that means we have our solid CS is 20%. It's calculated as percentage. And from this, we do our calculations to check out the LGS, low gravity solids, and high gravity solids, HGS, and solids, all solids calculation, drill solids, and all solids analysis calculation. This is a retort. Is the test maybe will take 1 hour or little bit more. Here we have a test for sand content. This sand content kit. It's this simple test is used to determine the volume percent sand size particles in a mud. The sand content in a mud system is estimated by weight screen analysis using a 20 mesh 74 micron screen. Here in this funnel we have inside screen is 74 micron. We will put mud here up to, we have mark here is mud up to here. Then we will put water up to here and check this sample and put it here to screening. All water will going from this opening and sand will be in the screen. Then we'll upside down this funnel again here to collect all sand here, and sand will be in the bottom here to check and calculate it as a percentage also. Here sand content is reported by percentage. It's around, it will normally it will be less than 1%. If it's more, you have to dilute your mud, you have to dump sand trap, you have to dilute with your mud with the fresh mud to decrease this sand content, and also run the sander and the filter and or mud cleaner and put a fine screen in the shaker, all this to control the sand content. Why we need the sand content as low as possible? Because sand is abrasive material. He makes some corrosion for the drilling string or so for directional tool. This test Next test is the methylene blue test. It's with abbreviation is MBT, methylene blue test. Sometimes also we said CEC is a cation exchange capacity. It's methylene blue capacity or methylene blue test indicates the concentration of reactive clay present in drilling fluid. Reactive clays are commercial bentonite or formation solids or drill solids when we are drilling the clay or shales. And we have this MBT kit. MBT kit is not, it's like the titration. We put here 1 ml of mud inside this flask, and put after that it's hydrogen peroxide. It's 50% of hydrogen peroxide. We will put 3% of hydrogen peroxide. We will put 50 ml and plus 10 ml of distilled water and 0.5 ml of 5N of sulfuric acid. We'll put all this mixture together and heating here in the hot plate for 10 minutes. After boiling in 10 minutes, we will dilute with distilled water up to 50 ml here in this flask. And after that, we will bring the methylene blue and put drop of methylene blue. It's a 0.5 ml methylene blue in the this mixture and shaking. And by this glass rod, we will put this drop here in the white paper and check the color. In the beginning will appear as a blue ring, and again add 0.5 ml of methylene blue and shaking, and again by rod check another drop till reach this greenish cycle of this is here will be endpoint. When we reach this, we have to calculate how many mils of methylene blue we added to the mixture from the start or the test, and these volumes of methylene blue we have to multiply 5 to report MBT in a pound per barrel. For example, if we use 2 mil of methylene blue, that means our MBT is 2 multiply 5 is a 10 pound per barrel. The next test is a pH. pH, we have two types, two methods to check the pH. Sometimes it's strips. It's just this here, these paper strips. Put just the paper strips inside the filtration from API filtrate and check which color to confirm our pH of the mud, or this pH meter. We can put the electrode of pH meter inside the mud or inside the filtrate and check by electronic way. We will give, this is sure is a more accurate because we'll give you in the two digits, but here you cannot check. It's just you can consider as a 9.5 or like this by estimation, but it's not accurate. This is for pH. For here for titration, we have too much titration. We collect the filtrate and make first titration is the BF, is the phenolphthalein filtrate. Phenolphthalein filtrate, that means the sample needed is a filtrate and the indicator will be phenolphthalein. We take 1 ml of filtrate and put on it on the titration dish 2 to 3 drops of phenolphthalein. The color will change from the filtrate color to pink after add phenolphthalein. Then we will titrate with the sulfuric acid 0.02N. It's 0.02 normality. H2 is O4. Then the color will change from pink to original color of filtrate. We will report BF as the mils of H2SO4 which we use to change the color from the pink to original color. When we خلاص take here take redness out and appear the original filtrate color, this will be endpoint of this test. We will check how many mils of sulfuric acid 0.02N we used, and this will be reported as a BF, as a milligram, as a mils. MF, this is methyl orange filtrate. It's we take also 1 ml of filtrate and put methyl orange or bromocrosol green. I prefer bromocrosol green because the endpoint is very clear. Because the methyl orange, the endpoint from is the changing color change from orange to yellow. Sometimes you cannot determine exactly the endpoint because orange and yellow is same yani colors. But here, for if we use bromocrosol green 4 to 6 drops, color change from blue to yellow. And also we will report the mils of H2SO4 as this is MF. We can use same sample of BF and continue the test of the BF, MF, but in that time you have to calculate MF as the total mils of H2SO4. That means mils to use to color change from blue to yellow, and plus the BF mils. This is for BF and MF, and this is for alkalinity. It's used to check the contamination of carbonate and bicarbonate and hydroxide. BM, this is same as a BF, but this is for mud. Here, phenolphthalein mud. This is alkalinity for mud. We take 1 ml of mud plus 10 ml of distilled water here just to dilute, because the mud sometimes is a dark color. You cannot see the colors. And when we dilute with the 10 ml of distilled water, then add phenolphthalein 3 to 4 drops. And also you will titrate with 0.02N of sulfuric acid, and color will change also from pink to original color, and BM reported as the mils of sulfuric acid what we used to change the color from pink to original color. Chloride, we have to make here, we have to take same sample of BF, or if you use same sample for BF for the test of MF, you have here, when you want to do the test of chloride, you have to do BF again first, then start to add potassium chromate 4 to 6 drops. Color will change to yellow, and we will titrate with the silver nitrate. We have two concentration of silver nitrate. We have low concentration is a 0.0282N, and we have high concentration is a 0.282N. Same test procedures is just the factor of for multiply. When we get the result, this will be different. If we use the high concentration, color will change from yellow to reddish color, and chloride will be mils of silver nitrate multiple 10,000 if we use this concentration. If we use the low concentration, we multiple it 1,000 only. And you have to select the titration solution here. The high concentration or low concentration depend on the type of mud. If your mud is the high chloride, you have to work with high concentration. If your mud is no chloride there, it's just only chloride of the water itself, you have to here to check with low concentration. For total hardness, we take also 1 ml of filtrate and put strong buffer 20 drops plus calmagite 4 to 6 drops, and color will be wine red, and we titrate with the editor 0.01 molarity, and color will change from wine red to blue or gray. It's just also take redness out. It's just no red remaining any redness. So this will be endpoint, and these mils of editor what we used, we will multiple 400. This will be total hardness in milligram per liter. For the calcium, we take same 1 mil of filtrate and put calcium buffer, or sometimes we put sodium hydroxide or potassium hydroxide, 20 drops, plus powder of Calver 2. This is Calver 2, just we take 1/4 of teaspoon for this is Calver 2. And also the color will change when we titrate with editor. The color will change from wine red to blue or gray, and also same result will be calcium will be equal mils of editor multiple 400 in reported in milligram per liter. Silicate, if we use silicate mud, this is special test, will not be for all mud. It's just especially if you use silicate, sodium silicate mud. We will take 1 mil of filtrate, and uh, indicator will be methyl red, color will be yellow, then add 0.2 N of hydrochloric acid, and color will change from yellow to pink. And after color be pink, put on the same sample 1 gram of sodium fluoride. This is powder. All again the color will be yellow, and here we will titrate with 0.2 NHCl, high concentration of hydrochloric acid, and again color change from yellow to pink. And this endpoint we will take mils of HCl 2N, what we used recently, multiple 0.2237 multiple 30. This is will give you silicate percentage. Also, we have test of KCl. We put we will take 7 mils of filtrate of and 3 mils of sodium perchlorate, and put it in tube glass, and in another tube glass we will put just only water to balance, and by manual centrifuge we will run manual centrifuge 1800 RPM, and precipitation, this is will going to some graph and check from this graph the KCl percentage. Also, if we use KCl in our mud, sometimes no KCl, no silicate isn't, so no need for this test. This is most of the testing. Now we complete all the test, but I advise all audience, all participants for this session, it's going to YouTube, uh, watch some videos to learn more about this test, because you have to see this test in your eyes, videos like this. And also if you have chance to go to if you have chance to go for training or to the field or like this, you have to do the test by yourself to know and to be professional in this test. We have some here pilot testing. This is pilot testing. It's an essential part of drilling fluid testing and treating. Pilot testing minimize the risk of sending a fluid downhole that may be incompatible with the formation to be drilled, or that may be ineffective under downhole conditions. It's what's the pilot test? We sometimes we have chemicals new for you go, for example, to the field and you find some chemical first time to see. You cannot uh, work with it directly. You have to make the pilot test in the lab and check this material, it's okay with this concentration. It's give you your good parameters, what you need, and after that you can apply this in your mud tanks. Generally, pilot test is concentrated on the physical properties such as rheology, fluid loss. However, it is important than chemical properties also to be evaluated. Pilot testing, it's just based on the fact it's if the concentration in the field is a 1 pound per barrel. We said, for example, we use this material soda ash or like this 0.25 pound per barrel. In the pilot test, this 0.25 pound per barrel, it will be 0.25 gram per 350 liter or 350 cubic centimeter. It's 1 barrel, it's equal 350 mil, and 1 pound equal 1 gram. This is pilot testing. You have to make from time to time the pilot testing to check if you want to increase your some concentrations for the chemicals, or you need to check this chemical is working or not. You put the suitable concentration, and you find is test results is not good. You have to make some pilot test to check what's the chemical, how your chemical is going on. For mixing procedures, if we need to mix mud, okay, for water-based muds, we have first type is a spot mud. This is a simple mud. It's a bentonite or the gel mud. It's called spot mud or gel mud, bentonite mud. It's just water and add soda ash. This is sodium carbonate. Soda ash to treat the water hardness, to treat the calcium. And if you have magnesium in our water, we will treat with the caustic soda. But normally, the magnesium will not be available in the water, except if the water in the come from the sea or you're working offshore or like this. Sometimes we have hard water. It has some too much calcium and magnesium. But normally we have soda ash to treat the calcium, and after that add bentonite. Here bentonite working as a viscosifier and wetting material also. And we'll take this mixture for hydration 8 to 16 hours. And after hydration finish, then we'll add caustic soda for pH. Usually concentrations will be in the mud program, but normally we use soda ash from concentration between 0.25 to 0.5, but also depends on your water hardness. Bentonite will be in the normal concentration will be from the 10 to 25 pound per barrel. Sometimes we work with the high concentration of bentonite, sometimes from 25 to 50 pound per barrel, but this is a special case. Normally from 10 to 25. And if you are not engineer and you are going to drill in this field here and you expect this formation, we have some clay, better to going with the low concentration of bentonite, and while drilling you will get the viscosity higher by the drill solids or by clay come from formation. So this is the simple spot mode. No filter, no fluid loss control in this, and this is very low cost mode. Okay, for polymer or salt polymer mud, we add water. This is the base fluid for water based mud. Soda ash to treat the hardness, caustic soda for pH, and fluid loss controller. Here, some such as starch, back, CMC. We have too much chemicals for these fluid loss controllers, and add after that viscosifier. It's such as XC polymer or Dolvis or Sansangam. And then add after that salt or KCl. This depends on the mod program. This is salt or KCl for salt for salinity or inhibition or weighting material. KCl also for inhibition and salinity. It's not used KCl for weighting as a weighting material because it's a very it's expensive. If you will going to higher mud weight, you will add barite as a weighting material. And up to here, up to viscosifier here, this is will be polymer mud. If you add salt, will be salt polymer mud. If you add KCl, will be KCl polymer mud. If you add silicate, will be KCl silicate mud. If you add BHBA, will be BHBA KCl BHBA mud. If you add saltix or polyamine, also this will be type of inhibitive mud. It's a polyamine, KCl polyamine mud. If you add glycol, you will call also KCl glycol mud. It depends on which type of inhibitor here to use. All this use for inhibition. Sometimes we use together, sometimes we use just one of them. But BHBA cannot be with the silicate. Silicate is a difference here. Silicate is a separate. But BHBA and saltix, polyamine, glycol, all this you can mix it together. This is for water-based mud. For OBM, oil-based mud, you have to mix in 2 tanks. The first tank will be base fluid, is a diesel or mineral oil, and add after that primary emulsifier and secondary emulsifier, and then add fluid loss controllers. Here for OBM, it's not like starch and back, it's asphaltic material. And you add also lime, and then add here in tank number 2 you will add water and just calcium chloride. This brine you will add it here. After you add all of this, you will add here the tank number 2, mix it together, and then after that you will add viscosifier, and after that you will add weighting material. This will be here OBM. But most of the time you are in the rig, you receive the ready OBM from the mud plant because it's too expensive to mix it in the tank, but sometimes you have to mix in the rig side. This is for mixing procedures. We have here mud reporting. The mud report must be accepted as a record of the past events and must be trusted as a true reflection of the fluid state at the time of reporting. Report, you have to reflect the truth, what actual we did, because this will be offset well for next well. If you put fake data in the mud report, this mud report will be useless in the future. and reports becomes more important than the fluids. If you make good report, you are considered as a good mod engineer, because reports talk and show yourself. Okay, mod reports must contains the mod properties. It's complete set of the test results. All the tests what we said, you have to make it twice a day at least and report it in the mod report in the DMR. And also hydraulics and rheological parameters. This is by calculations. Most of the reports have some software or like this is come automatically. You will not check, you will not calculate it by yourself. Also, the mod report must contains the rig operations and engineering comments. Engineering comments for example, today you mix some mud, you have to write mix 200 barrels of light mud to dilute, and we add some soda ash to treat the calcium. We add fluid loss control to enhance the filtration. You add some XCC polymer to enhance your rheological parameters like this. These comments will be useful for someone to uh, track the operation and know what's going on in the rig side for the office people, and also when they want to make new mud program or like this, and your office said well, you have to he has to, the office guys, they have to go to check the old reports and read all comments to be as a lesson learned. Also, mod reports must contains daily chemicals used and chemicals received, return with the cost. uh, this is for chemical tracking. Also, mod volume accounting, how many barrels you built, dilution, downhole losses, service losses, everything. Also, solid control equipment set, for example, the screens of the shakers, and how many running hours for the shakers or mud cleaners or centrifuge, the operational set, how many shaker, how screen size, the cones, how many cones of the uh, desander or desilter, the pressure, the mud in and mud out, mud weight in, mud weight out, the efficiency, all this should be reported. And also the time distribution for the day. It's how many hours of drilling, how many hours of circulation, how many hours of pull out of hole, how many hours of running in hole. Uh, Now we reach to last of this session, and I think we have some questions and discussion. Let us start our discussion and question and answers. I will check here the questions. Maybe the moderators some. Okay, here. KCL chart, how it's being generated. It's will generate with if you want to generate by yourself, you have to uh, make too much test and readings and check to, but it's ready. It's available in the books or like this, and but by you can make it. It's just a straight line from 0 0, and you have precipitation and percentage. You can make it, and then it's easier to. I will bring it the chart next session inshallah to see you. Which better is used? Which is better to be used, KCl or NaCl? And is an NaCl used for inhibition? Yes, NaCl used for inhibition because it's each salt you can use it for inhibition, because one of mechanism of inhibition to increase the salinity of your mud to make the differential osmosis. KCl is better than NaCl because the KCl is make cationic exchange also. Is but sometimes we use it together. It's KCl and NaCl because the KCl is very high, expensive. We have to use little small concentration of KCl and full concentration of NaCl. Okay, what's the most used type of mud in Sudan? In Sudan, used most of the mud. It's a spot mud, KCl polymer, and silicate mud. Sometimes glycol mud for horizontal one. Viscosity measurements. What is the volume of the mud should be used to determine the time in the funnel? Marsh funnel, you have to fill the Marsh funnel till the mark, and then let to mud to fill the mud cup till the mark also. But the mud cup is a cup. It's mud cup. It's we volume of the mud cup is the card of okay, mixing in the OBM tank one. Explain again, please. OBM, for OBM you have you will mix in the tank number one. It's diesel and emulsifiers, primary and secondary emulsifier, and fluid loss controller and lime, and then add the brine from the tank number two, and after that add viscosifier to the mixture and weighting material, barite or calcium carbonate for the mixture, and this will be OBM. What should be the filter cake maximum thickness downhole? Is not, we have not number as a maximum. We need it as low as possible, and normally we have for API filtration, our thickness will be 1 to 32 or 2 to 32. It's sometimes 3 over 32 inch or 4 of 32 inch, but it's 4 over 32 inch will be you consider as a thick filter cake. Okay, why we choose the 600 or 300? Okay, this is RPM readings in Viscometer. It's a simulation in the hole. For example, from 600 up to 100, this will be in annulus. The shear rate across our mud in the annulus in the range between 100 to 600. So when we need to calculate, or that's why we check this, we take this number 600, 300, 200, 100, because this simulation for the shear rates on the mud in the annulus, and 6 and 3 on horizontal low bits, low side, and degree in degree between 30 to 60 degree, or in the mud tanks. The shear rate on the mud tanks is less than 10. It's the 3 and 6. It's the 3 and 6 is considered as a simulation for a mud tank or a low side in horizontal wells. And more from 300 to 600, this is inside the drill pipe also. In the bit getting nozzle, we have high shear rates. Here we have more than 10,000, but this is no need to check in the bits, because in the bits no need for shear rates or like this. But for annulus, this is because our concentration, our concern here is a hole cleaning. Okay, we'll check for this lecture material. I will discuss with Academy for this. What is the benefits of measuring? Okay, BF and MBM. I said that BF and MF, BF and MF. This is to check the concentrations of carbonate and bicarbonate and hydroxide in the mud. This is considered as a contamination. If you have you want to know how many carbonate or bicarbonate in your mud, and this is acceptable range or not. This is and also because, so for example, you have source of carbonate, it's the soda ash, because soda ash is the sodium bicarbonate. If you didn't add soda ash to your mud and you get your MF is high, that means you have some carbonate from the water or from the formation. This is considered here as a contamination. You have to treat it. BM, it's also excess lime, for excess lime and mud alkalinity. CO2, CO2 is we will come to this contamination in the last session, inshallah. We will talk about the contamination in details. CO2 considered as an acidic gas is a contamination, and sometimes, yeah, carbonate is a change your viscosity, sometimes make hump in your viscosity, and we will discuss about this in last session, inshallah. Before the mud mixing, what type of data on the formation required on the project scope before starting to mix mud for drilling. Okay, what type of data on the formation? You have to know the description of formation. It's the formation is clay or sandstone or limestone anhydride, like this, to check, just to make your mud ready to deal with this formation. For example, if you have high reactive clay, that means you have to raise your level of inhibition. If you have if you are going to drill the anhydride, for example, you have to know you will get high contamination of calcium, and your pH will be down. You have to deal with this also. Why we conduct titration test? To check our mud, its barometers is okay or not. Because, for example, we need our mud has a level of chloride contents. For example, as per mud program, we need this. We need our chloride in your mud. It's 150,000 milligram per liter. You have to check, and you check your mud to see if your chloride is the same as the program or not, to give the good performance in the hole. For you will check calcium to treat it. You will check the BF and MF to treat the contamination of the carbonate of or bicarbonate. You will check the MBT to know your how is the reactive clay you have. Your inhibition is good or not. You will check the KCl or silicate to know the depletion rate, because you will mix the concentration of KCl, but this KCl is consumed inside the hole. You have to check and make the test and compensate this value of depletion rate. Okay, I think no more for questions. It's Selma is here. PetroNile.
Mr. Ghassan, for this insightful, enlightening, useful session. And first of all, I want to send a sincere apologize to everybody. It sounds like it's end up. So a big and great thanks to everyone, and we cherish that you're being here with us today. Again, just make sure to join the link where you can attend in order to have your certificate. And if there is anything you want to add or to ask for, you may write it down before warm up. So, Mr. Ghassan, and if there is anything in the chat, we will share it together.
Okay.
Okay. For everybody, make sure to join the link and do the attendance. It sounds like there is no more question.
Yes.
Yeah, it looks so. So remember that all sessions are viable on YouTube channel, so you can rewatch it in your convenience. Stay safe and stay home, and goodbye. Thank you, everyone.
Okay, thank you.
Till we meet up again.